Hello everyone, welcome back to my channel. I am Vamshik Shetty, pursuing third year B in Sri Venkateswara College of Engineering, Bangalore. Today in this video, we are going to discuss about the one of the major topic in the data science and the visualization, that is understanding the k nearest neighbors, that is KNN algorithm. Now let us discuss about the KNN algorithm. The k nearest neighbors algorithm, which is in short we call as KNN algorithm. The k nearest neighbors algorithm is a supervised machine learning method employed to tackle classification and the regression problems. This KNN algorithm is used for both for the classification and the regression problems. Evelyn Fix and the Joseph Hodge developed this algorithm in 1951, which is subsequently expanded by the Thomas Cover. Now let us discuss about the definition of the KNN. The nearest neighbors is a non-parametric and the lazy learning algorithm that classifies a new data point based on the classes of its k nearest neighbors. The value k in KNN is a user-defined constant that determines the number of nearest neighbors to be considered when making the classification or the prediction. The intuition behind the KNN is to consider the most similar other items defined in terms of their attributes, look at their labels, and give the unsigned item the major vote. If there is a tie, you randomly select the among the labels that have the tied for the first. So this is the basic overview of the KNN. Now let us discuss about the overview of the KNN process. Here we mention the six steps which we are going to observe in the KNN process. The first step is the decide on your similarity or distance metric, and then we are going to split the original label dataset into training and the testing data. Pick an evaluation metric. The classification rate is good one. We'll explain this more in a bit. Run the KNN a few times, changing the K and check the evaluation measure. Optimize K by picking the one with the best evaluation measure. And once you have chosen K, use the same training set and now create the new test set with the people's ages and the incomes that you have no labels for and want to predict. So this is about the steps. This is about the steps which we are going to use in the KNN process. Now here we can take an example. Here we have taken the two data sets. The one of the data sets in the red color and the second data set in the blue color. And then we have gone for the one of the new point that is in the green color, and then we are going to conclude that this green color dataset is near for the blue color or the red color by using the KNN algorithm. This is the one of the example which we have done in the done using the KNN algorithm. And now let us see the different distance matrices that we have used in the k nearest neighbors algorithm. Here we have taken the six major distance matrices that we have used in the KNN algorithm. The first and the common and the major user distance is the Euclidean distance, and the second is the Manhattan distance, and the third is the cosine similarity. The fourth is the Jacquard distance, which is also called as the similarity distance metric distance, and the fifth is the Mahalanobis distance, and last is the Hamming distance. These are the major six distance matrices which we have used in the k nearest neighbor algorithm. Now let us discuss each and every distance matrices which we have used in the KNN. The first and foremost method is the Euclidean distance. This is the most distance widely used in the KNN process, and this distance is the this is the distance most widely used as one. It is the default metric that a scalar library of Python uses for the k nearest neighbors. It is a measure of the true straight line distance between the 2 points in the Euclidean space. Yeah, here in the figure we can see that between the 2 points we can measure the straight line distance by using the 2 points. That is about the Euclidean distance. Now let us discuss about the second distance matrices, that is the Manhattan. This distance is also known as the taxi cab distance or the city block distance. That is because the way in this distance is calculated. The distance between the 2 points is the sum of the absolute differences for their Cartesian coordinates. As in the figure, we can see that the distance can be calculated in the straight line only, not in the diagonal way. And the formula for the Manhattan distance is the distance of the x comma y is the summation of the I to k, that is the mean of the xi minus the yi. This is about the Manhattan distance. Now let us discuss about the third method used in the KNN, that is the cosine similarity. This distance metric is used mainly to calculate the similarity between the two vectors, and it is measured by the cosine of the angle between two vectors and determine whether the two vectors pointing in the same direction. It is mainly used in the vector points only, and the formula used in the cosine similarity is the cos of x comma y is equal to x into y whole divided by uh, mod of x and the y. This is about the cosine similarity, and you got to know that the cosine similarity is only used when we are going to deploy the vectors only. And then we are going for the fourth distance matrix is used in the KNN, that is the Jaccard distance. This Jaccard distance is also called as the similarity distance matrix, where this measures how similar the two sets are. Imagine comparing the two friend list. You look at how many friends are in the both the list intersection and how many unique friends are in either the list. That is the union. And the Jaccard similarity is the ratio of the intersection to the union. Higher values mean more similarity. When we are going to get the higher value in the Jaccard value, then it means that it has the most similarity value. The Jaccard distance is defined as it is the ratio of the intersection and the union, where A intersection B divided by the A union B, and it is also derived as the some other formulas. So this is about the Jaccard distance, the similarity distance. Now let us discuss about the fifth distance matrices used in the KNN, that is Mahalanobis distance. It is also similar to the Euclidean distance, but takes into account how the data is spread out, that is the correlation, and adjusts for the different scales in the data. First, the main difference between the Euclidean distance and the Mahalanobis distance is the correlation part. The main steps used in the Mahalanobis distance is the first step is the calculation of the covariance matrix, and then we are going to invert the covariance matrix. In the calculation part, the covariance matrix represents how each feature varies with the every other feature. It helps understand the relationships and the spread of the data. And in the invert of the covariance matrix, the inverse of the covariance matrix is used to adjust for the relationship between the features. So this is about the Mahalanobis distance. Now let us discuss about the last distance matrix used in the KNN, that is the Hamming distance. Mainly it is used for the strings of the same length. It counts how many positions have different characters. And for example, comparing the cat and the bat gives the distance of 1, because only the first letters are different, and uh, only the A and T are same, but C and B are different, so it gives the distance of 1. And also let us take an example of the olive and the ocean. It gives 4, because O is only the same word, remaining the 4 words are different, so it gives the distance as 4. This is about the, so it is mainly used for the strings of the same length, and the formula used in the numbers values are the d of distance of the x comma y is the root of x minus whole transpose s inverse of the x minus y. This is the formula used for the Hamming distance, and these are the overall distance matrices used for the KNN, that is the Euclidean distance, Manhattan distance, cosine similarity distance, Jaccard or the similarity distance, and the Mahalanobis distance, and the Hamming distance. These are the 6 methods used in the KNN. Yeah, that's it for this video. Thank you. For more videos, please like, share, and subscribe the channel. Thank you.